how would you get the derivative of x raised to x raised to x, yada yada yada. So yeah, it's for you it's impossible, right? Like x raised to x raised to x raised to x, so on and so forth. And how are you going to get the derivative of that? It seems impossible. It's not that it's impossible, it's actually possible. Even though it's in infinite, it's obviously it's infinite because there's like an endless number of x as your exponent, x raised to x raised to x raised to x. It's like a stairway to heaven. Well, don't worry, it's not actually that hard. Okay? Let's just use our critical thinking or reasoning for a moment. You see, this x raised to x raised to x raised to x, is just the same as x raised to x raised to x raised to x, x, and so on and so forth. All right? But let me tell you, go back again. Y is equal to x raised 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 to x, right? So what does it mean? If y is equal to x raised to x raised to x and it goes infinity, that means actually I can substitute some portion here as y. Like for example, I can have like until I reach like the third exponent, which is x, while the rest, this one, I'm going to represent it as y, okay, as an exponent for this x here above. So meaning I will have y is equal to x raised to x raised to x raised to y. I can do that because again, y is x raised to x raised to x. So it goes on infinity. It's an endless number of x as your exponent, right? So I can do that, right? Or much better, actually, much better is what if the exponent of your base x here, this one, okay, from this up to infinity, we can represent it as your y. So instead of y is equal to x raised to x raised to x, I can just simply rewrite this as y is equal to x raised to y. I can do that because again, since y is equal to x raised to x raised to x yada yada, that means again, in one portion, we can substitute it as y. Therefore, in this case, we can substitute this as y. All right. So therefore, instead of having like these or these, you know, we can have this instead, which is much simplified, much more simplified and better. All right. Now, what are we going to do? Now we're going to get the derivative. By how? By applying logarithmic differentiation. When I say logarithmic differentiation or log diff, okay, it has something to do with logarithm. You already know. Okay, I already stated that. And number two is implicit differentiation. So if you want to apply logarithmic differentiation, you must have a logarithmic function and you must know how to do implicit differentiation. So in here, basically, the first thing you will do here is you must put logarithmic functions on both sides and make sure they are the same. For example, I will use log, the common log, right? So here, I can put the common log on this equation. So I will have log of y is equal to log of x raised to y. I can do that. You know what I mean? Just like that, right? Or maybe you could use log base 2 instead. So you will have log base 2 of y is equal to log base 2 of x raised to y. But for me, just use ln. Just use ln. In fact, this is actually commonly used, I do believe, by the engineering students like myself. So we can just use ln instead. So instead of log or common log, we can just use ln. Okay. So instead of just putting log y or whatnot, we can just put ln, wait, hold on. Ln of y is equal to ln of x raised to y, right? We can do that. So why I pick ln, all right? Later I'm going to explain that. So in here, what's next? Here, what we're going to do is we're going to expand everything. If we can still expand them, that's good. So here you see this, we can expand this one by applying power law of logarithm. Because remember, if we have ln of a raised to n, let n be the exponent for the argument or your a, whether if it's a number or a variable. What we're going to do here is you're just going to bring it down. So you will have n times ln of a. So here we have y, right? We can bring it down here. So as a result, you will have ln of y is equal to y times ln of x. That's it. Okay. And now here's the thing. It is what? Expanded. Okay. It's already expanded. And why do we need to expand it? So that we can differentiate them easily. Like we can differentiate each of the terms, functions rather, easily. Okay. So in this case, we can differentiate them. And that also answers the question why I would rather pick ln instead of log or log base 2. Because if you're going to differentiate ln, remember that the derivative of ln of x is what? 1 all over x. Compare that in differentiating a log. Okay, the derivative of log base b, let's just say b as the base of the logarithmic, then x. In here, what will be the derivative? You will get 1 all over x times ln of b. So here, which one is better? Is it ln of x or the derivative of log base b of x? So of course it's this, which is why we will rather use ln, so that if we're going to use it in differentiation, especially after you expand everything, it's easy. All right. So let's get the derivative on both sides. Okay. Let's get the derivative of ln of y. So here you will apply implicit differentiation. Basically, if you see a variable of y, after you get the derivative of it, put y prime or dy all over dx. For example, I have y squared. Get the derivative of y squared. So here, I will use power rule, in which you will have 2y raised to 2 minus 1. But remember, after you get the derivative, you put y prime beside it, or dy all over dx. Okay? So it's up to you, dy all over dx or y prime, it's up to you. But point being, after you get the derivative of the function that has y as an independent variable, don't forget to put y prime. So therefore, the derivative of ln of y is 1 all over y times y prime. Okay? Here, we will do product rule because we have two functions here. One is a y and the other is ln of x. Okay? So let's take this slow, okay? Because I don't want viewers will be confused on how I got the derivative of this one, all right? So you will use product rule. Okay, remember that in product rule, okay, suppose let's just say you have two functions stick together. Okay, u and v. U and v. All right, and you want to get the derivative of u and v. So the result would be u dv plus v du. Okay, if you want to get the derivative of u and v, the answer for that is u dv plus v du. Okay, basically this is the formula of product rule. Okay, so let's get the derivative of y times ln of x. Okay, so I will let u as y, getting the derivative of my u, or y rather, I mean, that would be just y prime. Next, if I'm going to get the derivative of v, which is ln of x, wait, I will represent v as ln of x, and getting the derivative of your v, that would be 1 all over x. All right? Now, if you're asking me, how come that I got the derivative of y as y prime? Remember that if you're going to get the derivative of a term that has a constant term, which is a, and a variable that is in first degree, or basically it has no visible exponent, just like that, just x, all you need to do is just copy the constant, all right? So therefore, if you're going to get the derivative of y, the answer is 1, okay? Because the constant behind y is actually 1, all right? But remember, you're differentiating a y variable, so don't forget to put y prime. So you have y prime as a result. Okay, so now we will substitute it in that formula. Okay, so here you will have u y times dv ln of x. Am I right? No, no, no. 1 all over x. Sorry, 1 all over x plus v ln of x times du y prime. Okay, so combine everything, you will get y. Wait, y all over x plus y prime times ln of x. That's it. That's the derivative of your y times ln of x. Okay. So let me just put it here. Okay. And you know what? Let me just how to say this? I wait, I'm just gonna put it that way, an arrow here. Okay. Then let me just copy again the equation. Y 1 all over y times y prime is equal to y all over x plus y prime ln of x. Okay, that's it. Now here, yeah, we're going to find our y prime because after we get the derivative, just like in implicit differentiation, we're going to find y prime or solve for y prime. In other words, make y prime alone. Okay. First and foremost, let me multiply this one. 1 all over y times y prime is y prime all over y. Right? Then let me just copy this. So here's what I'm going to do. First, okay, for me to find the y prime, I will group all the terms that have y prime on one side. So you see, I have one y prime all over y on the left and y prime times ln of x. Both of them have y prime. So what I can do is I'm going to group them all in one side. You can group them on right side. Okay, by the way, it's up to you. But for me, I'm going to group it on the left side. So you have y prime all over y plus, no, minus y prime times ln of x. Remember, if you're going to transpose a term on the right or any side, you're going to change its sign. So from positive to negative. Then y all over x. Okay? Then here, after you group all the terms that have y prime, you're going to factor out y prime here. Okay? So factor out y prime here. You will get y prime times quantity 1 all over y minus ln of x is equal to y all over x. Then after that, okay, since we factor out y prime here, we're going to divide both sides by 1 all over y minus ln of x on both sides so that we can now find our y prime. All right. So here we can cancel out here. So the result here would be y prime is equal to y all over x all over 1 all over y minus ln of x. Okay, that's it. Okay, let me just check if my solutions are correct. Yeah, yeah. Okay, they are correct. Okay, so that's it. So now you may be thinking this is the answer, but let me just simplify because I don't like the way how the answers form like this. So let me just simplify them, okay? So here, let me combine them into one whole fraction. So by how? First, you multiply the denominator by that the function beside it. So y times negative ln of x. So you get negative y ln of x. Okay? Then what's the product? You're going to combine it here. So 1 plus negative y ln of x, you will get 1 minus y ln of x all over y. All right. Then we can simplify it one more time because you see, if you have this type of fraction, y all over x, all over 1 minus y ln of x all over y, here we can simplify it one more time. By how? Okay. So here, if you're going to simplify it, all you need to do is simple. You copy the fraction, you copy the numerator above first. So the numerator above is y all over x. So copy it here, y all over x times the denominator, but you switch the position. Okay, so you will get y all over 1 minus y ln of x. That's it. Now, why though? Okay, because this is how would you simplify a fraction in which there exists a fraction on both sides, like A all over B, all over C, all over D. If you want to simplify this, okay, just copy the numerator A all over B times the denominator, but the positions are switched. So instead of C all over D, it's D all over C. Then multiply them together, A times D, AD, B times C, BC. And that is what we're going to do here, all right? So here we will have y prime is equal to, multiply them together, you will get y squared, then x times quantity, 1 minus y times ln of x. It's simplified, all right? Is this our final answer? Not yet, because there's one more thing there's one more thing we're going to do, okay? And what would that be? So remember that our y once again is what? X raised to x raised to x raised to x raised to x, right? So in that case, we can replace y as x raised to x raised to x raised to x. So therefore, you will have what equals 1? Quantity x raised to x, yada yada, okay, squared all over x times quantity, wait, x times quantity, y minus your y, we have x raised to x raised to x raised to so yada yada, then times ln of x. And that for me is your final answer. That's it. That is how you find the derivative of x raised to 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 x. And yada yada. Right? That's it. You can still simplify this one, by the way. Like, you see this one? Okay. Remember what's that again? This one? Right? Remember this one? The power law of logarithm? If you have an exponent, whether if it's a variable or not, you can bring it down, in which you will have the exponent times ln of a. And you can do it in reverse way, where you can just simply have what? What equals what? Have n raised to a. So you will have ln of a raised to n. You can do that, okay? So let me just copy this one, and let me just adjust the denominator. So let me fix that. All right, let me fix this one. That's it. Okay. So here, yeah, we can bring up this one. It's an exponent for your x here. Okay, that's it. And remove this one. Okay, that's it. Then put the parenthesis here. Okay. Then yeah. Wait, hold on. Yeah, that's it. Right, that's it. Right? There we go. So it's up to you whether if it's this is your preferred answer or the answer above. Right? It's up to you.